Hello everyone. Today's lesson is on translations. If you recall, translations is when you slide a shape to a different spot on the coordinate plane. You're just sliding it somewhere else, but it remains the same size. Alright, that's what we're going to go over today, translations. Okay, now the first thing we're going to go over is this arrow that you see right here that's telling us where to move our pre-image to get the image. Okay, we have a picture showing this arrow telling us to move this triangle to this spot, and it's the same thing over here. Alright, we have this triangle, which is our pre-image, and this arrow right here is telling us exactly where to move the pre-image to get the image. That arrow is called a vector. Okay, that arrow is called a vector. As you're going to see in a second, the vector is going to show us which direction they want us to move the figure and exactly how far. Okay, which direction and exactly how far. Okay, now before we go into our first example, I just want to go over how you would write a vector. Okay, to write a vector, the symbol is this. That's the symbol, and on the bottom you would write 2 points, the initial point of the vector and the terminal point of the vector. Alright, so in this example here it would be vector EF, whereas in this example right here it would be vector C prime. Okay, again, that's just how you would write the vector, which is this line right here, vector. Okay, that's the line telling us where to move the pre-image to get the image. That's the symbol for a vector, and underneath it you put the initial point and the terminal point. Okay, so like in this one right here, it shows right here you would write vector EF that way. You put the symbol for a vector on the top and the initial point and terminal point on the bottom. And in this case you could also name it vector V because of the V that's right here. Okay, so you could also name it vector V, vector EF or vector V. Alright, let's move on to our first example so you could see how you use vectors. Okay, in our first example, very simple. They're asking us to draw the image of triangle ABC after a translation along vector V. So right here, this is vector V. Okay, now let me tell you how I would figure out exactly where to move these points. If you remember how to get the rise over the run from Algebra 1, it's almost the exact same thing. It's pretty much the same thing, right? So look, this is my initial point right here. Oh, I'm sorry. Let me try that again. This is my initial point right here, and this is my terminal point. So obviously it's telling you to go to the right and up. So just count how long the vector is. If you count to the right, it's going 1, 2, 3, 4 units to the right, 4 units to the right, and up 1, 2 units up. So I'm going to do that exact same thing to all 3 of these points. Let's start with A. Alright, so I'm going to move it 4 units to the right, 1, 2, 3, 4, and 2 units up, 1, 2, and that's where A prime would be. Now I'm going to do the same thing with point B. 1, 2, 3, 4, and 2 units up. 1, 2. That's where B prime would be. And now C, same thing. 1, 2, 3, 4, and 1, 2. That would be C prime. And now I just got to connect the dots. Let's see how good I could do that. Okay, and that's it. I'm done. That's my answer. I've done a translation of the pre-image triangle ABC to get the image triangle A prime, B prime, C prime using this vector. Okay, the vector tells me what direction and how far horizontal and vertical I have to move the triangle. Alright, here's the drawing from the book, but it's basically the same thing. Let's look at another example. You're going to be graphing these on your assignment, okay? Okay, so here they're asking us to draw the image of triangle ABC after a translation along vector V. Alright, so as you can see, here's our vector. This one's telling us that we got to move it down and to the left. Down and to the left. Okay, so again, here's my initial point. Here's my initial point. And here's my terminal point. So I'm going to count the movement horizontal and up and down, okay? So horizontal would be to the left, 1, 2, 3, 4, 5. 5 times to the left. Okay, let me write that here. 5 times to the left. And down, 1, 2. 2 units down. So 5 to the left and 2 units down. Okay, now I'm gonna go ahead and move points A, B, C to get points A prime, B prime, C prime. Alright, so A, I'm gonna go 1, 2, 3, 4, 5 to the left and 1, 2 down. And that's where I'm gonna put A prime. B, 1, 2, 3, 4, 5 and 2 down. That's B prime. And C, 1, 2, 3, 4, 5 and 2 down. And there's gonna be my C prime. Connect the dots. And that's it. There's my answer. Super simple. I would have you guys try this, but without graph paper, it's kind of hard to do it through the internet. However, you'll have plenty of chances to graph it on your assignment. All right, let's go to the next part. All right, same thing. I'll just do a couple quick examples so that everybody is absolutely sure that they understand. All right, so number 1, here's my vector. It's telling me I gotta go. I could do down first if I want. It's not a big deal whether you want to go left and right or up and down first. So if I go down first, obviously it's 2 units down and 1, 2, 3, 4 units to the right. So 2 units down, 4 units to the right, however you want to do it. So let me just change my pen color here to red. Alright, so if I want to start with C, it would be 2 units down and 1, 2, 3, 4 to the right, and that would be C prime. Now B, 1, 2, 1, 2, 3, 4. And there's B prime. Last one is A, 1, 2 down and 1, 2, 3, 4. There's A prime. And there's my answer. Alright, right here, again, same concept. So this one's telling us to move up and to the right. So I'm going to go up. This is just 1 unit up. 1, up, and 1, 2, 3, 4, 5 to the right. So 1 up and 5 to the right for all of them. So A goes up 1 and 1, 2, 3, 4, 5. There's A prime. B is 1 up and 1, 2, 3, 4, 5. There's B prime. And C is 1 up and 1, 2, 3, 4, 5. There's C prime. And I'll do one more. This one's telling us to go to the left and up. So to the left twice and up 3 times. 1, 2, 3. 3 times up, okay? So I'm going to do that for every single point. Start wherever you want. I'll start with C. So 1, 2 to the left and 1, 2, 3 up. I'll put C prime. B, 1, 2 to the left and 1, 2, 3 up. There's B prime. And A, 2 to the left, 1, 2, and 1, 2, 3. Connect the dots. Okay, and there you go. And as you can see, the shape is still the same. If you look at this side and this side, they're still the same size, all right? So everything stayed the same. All right, let's go on to the second part of our lesson here. There you can see the answer from the book, which will be in the PowerPoints when I upload them to our Microsoft Teams webpage. Okay, now, same thing, but now you're going to have to write the vector. You're going to have to write the vector in using this type of notation, which I'll go over. It's very simple. Okay, so as you can see up here, it says a vector can also be named using component form. Sorry for my crooked line. Alright, but a vector can also be named using component form. Basically, you're going to write the vector in this form right here. Now notice, on the outside, those are not parentheses. It's that. Those are the symbols. Okay? And in the middle where you have the A and the B, what you're going to write is this. You're going to write what numbers do you add to the x coordinate. That's what A is. A is what number do I add to the x coordinate. And B is what number do I add to the y coordinate. Let me show you what I mean, alright? If you recall, I said that the x coordinate controls movement left and right, and the y coordinate controls movement up and down. Okay, so if you move the figure to the right, you're gonna. Sorry about that. Hold on. If you move the figure to the right, okay, you're gonna add to the x coordinate A. If you move it to the left, you're gonna have to subtract. In other words, if you add a number to x, it moves the shape to the right. If you subtract a number to the x, it moves the shape to the left. I'll say it again. If you add a number to the x coordinate, it moves the shape to the right, whatever number it says there. And if you subtract a number to the x coordinate, it's going to move it to the left by that many times. Now, same thing with the y coordinate. If you add a number to the y coordinate, it's going to move it up that many times. And if you subtract a number from the y coordinate, it's going to move it down that many times. Okay? So A represents what number you add or subtract to the x coordinate, and B represents what number you add or subtract to the y coordinate. In this example, since you're moving the vector is telling us to move the figure to the right 5 units. That's why you're adding 5. And you put the adding 5, you write it like that. You just put a 5 there for the vector. And you're moving it up 3 units, so you put a 3 there for the vector. And that's called component form. So the component form for vector PQ would be 5, 3. Alright, let's look at an example here. If it doesn't make sense, hold on 1 second. Alright, so look. Here's our vector. Before I look at anything else, what that means is that the positive 4 tells me that they want me to add 4 to all the x coordinates. They want me to add 4 to all the x coordinates. And the positive 6 here tells me that they want me to add 6 to all the y coordinates. That's what this means right here. They got that information from right here. Again, right here in this column, right here, that's showing us what do they want us to add or subtract to the x coordinate. In this case, it's positive 4, so that means you got to add 4 to the x coordinate. And in the other one, right here, they're telling us what we're supposed to add or subtract to the y coordinate. Since we have a positive 6, we're going to add that to the y coordinate. So here are here are our coordinates for the pre-image. Where did they get that from? It's right here in the question. The pre-image coordinates. It says it right here. They just rewrote them down here, okay? All you're going to do is take each one of these x and y's and do this rule to it. You're going to add 4 to all the x coordinates and 6 to all the y coordinates. Okay, so first one, x is negative 2. Negative 2 plus 4 is positive 2. The y coordinate is 1. 1 plus 6 is 7. And that's it. That's my first coordinate for my image. Let's take the next one. Negative 3. That's the x coordinate. And the rule is telling me, or the vector is telling me, whatever x is, I got to add 4. Alright, negative 3 plus 4 is positive 1. The y coordinate is negative 2. The vector tells me that whatever y is, I got to add 6. Negative 2 plus 6 is positive 4. And the last one, the x coordinate is negative 1. The vector is telling me that whatever x is, you got to add 4 to it. Negative 1 plus 4 is positive 3. The y coordinate is negative 2. The vector is telling me that whatever y is, I got to add 6 to it. So negative 2 plus 6 is positive 4. Okay? Now we graph the coordinates of the image, which are right here, and that shows us the translation. Okay? Let's look at another example here. Let's look at another example. All right, here we got to fill in the blanks. Notice there's nothing drawn for us. We got to do both the pre-image as well as the image. All right, so let's get the coordinates first and then I'll draw everything, okay? So it gives us the pre-image coordinates, but here's the important part, the vector, okay? The -2 means that whatever x is, we're going to subtract 2 from it. Whatever x is, we're going to subtract 2 from it. So when this was a positive number, we added the number to x. But since this is a negative number, it's going to be x minus 2. That may be a little confusing. But again, if this is a positive number, that means you add that number to x. And if it's a negative number, as it is in this case, that means whatever x is, you're going to subtract 2 from it. Now over here, the b of the vector component is the number 3. It's a positive 3, so you're going to add 3 to all the y coordinates, all right? So they've already filled out the pre-image coordinates here, so I'm just going to take them one at a time and apply that vector, what the vector is telling me to do to the x and the y coordinate. All right, so my x coordinate here is 3. I got to do 3 minus 2, which will give me 1. The y coordinate is 0, so I got to do 0 plus 3, which will give me 3. On this one, the x coordinate is 2, so I got to do 2 minus 2, which is 0. And the y coordinate is negative 2, so I got to do negative 2 plus 3, which is positive 1. Over here, the x coordinate is 4, so I got to do 4 minus 2, which is 2. And the y coordinate is negative 2, so I got to do negative 2 plus 3, which is positive 1. Okay, now I'm going to graph both the pre-image as well as the image. All right, let me do the pre-image in blue. All right, so they didn't give us, well, point A is at 3 comma 0, so point A is at 3 comma 0. Okay, point, they didn't write the letters here. Let me just write them out here. A. I'm getting that information from up here, by the way. All right, B is at 2, negative 2. And C is at positive 4, negative 2. Positive 4, negative 2. So here's C. All right, so that's my pre-image. All right, let me change the pen color to red, and I'll draw the image. So A prime is at 1, comma 3. That's A prime. B prime is at 0, comma 1. And C prime is at 2, comma 1. And that's it, I'm done. Just connect the dots and I'm done. Easy peasy. Alright, so again, the blue one is the pre-image, the red one is the image, and I followed what it said in the vector. And I have one more question here. It says the image will be in quadrants. If you remember, I told you you could remember the quadrants by thinking about how you write the letter C. The letter C, you write it like this. You start in the top right box, you go to the left, then down, and then to the right. 1, 2, 3, 4. So the 1, 2, 3, 4. So the image in this case is in quadrant 1. The image is in quadrant 1. Okay, let's move on to the next slide. Alright, there's the answer from the book. As you can see, everything I did was correct. Alright. Okay, so let me do a couple more examples here. Again, it says draw the pre-image and the image of each triangle under a translation along this vector right here, which is saying negative 4, comma, positive 1. Right? Here are coordinates for the pre-image, and I'm going to come up with the coordinates for the image. All right? Actually, before I start, let me just draw the pre-image in. All right, so A is at 2 comma 4. B is at 1 comma 2. and C is at 4, comma 2. Well, more or less. Okay. All right, now. Okay, so now I'm going to come up with the coordinates of the image here in red. Let me label them A prime, B prime, C prime, just to make it easier to keep track of what I'm doing. Okay, so when I get my coordinates for point A, the x coordinate is 2, and the vector is telling me I got to subtract 4. So 2 minus 4 will give me negative 2. The y coordinate is 4, and this is positive 1. So that means I got to do 4 plus 1 to get 5. Now let me do the same thing with the b coordinate. The b coordinates. Alright, the x coordinate is 1, and the vector is telling me I got to subtract 4 from the x coordinate. 1 minus 4 is negative 3. The y coordinate is 2, and the vector is telling me I got to add 1 to this number. So 2 plus 1 is 3. And for C, the x coordinate is 4. I got to do 4 minus 4, which will give me 0. And the y coordinate is 2. I got to do 2 plus 1, which is 3. Alright, so those are the coordinates for my image. Let me graph it, and let's make sure it looks right. Okay, so A prime is at negative 2, positive 5. Okay, B prime is at negative 3, positive 3. And C prime is at 0, positive 3. Alright, and there's my answer. Okay, let me do the same thing with number 6. Again, we're using these vectors, alright? So, again, let me start off by graphing the pre-image in blue, just to keep everything consistent. Okay, so we got P is at 2, comma, negative 1. Positive 2, negative 1. That's point P. Q is at positive 2, negative 3. And R is at positive 4, negative 3. Alright, so there's my pre-image. Alright, now I'm going to change my pen color to red, and let's get the coordinates of the image. So image. Oh, almost wrote A prime. It's P prime. E prime, Q prime, and R prime. Okay, so for P prime, the vector says whatever x is, you got to subtract 4 from that number. Since x is 2, I got to do 2 minus 4. 2 minus 4 is negative 2. And whatever y is, I got to add 1 to that number. Negative 1 plus 1 is 0. Now I'm going to do the same thing with q prime. Okay, to get q prime. So q, the x coordinate is 2. Whatever x is, I got to subtract 4 from it. So again, 2 minus 4 is negative 2. And the y coordinate is negative 3. I got to add 1 to it. So negative 3 plus 1 is negative 2. And to go from r to r prime, r is positive 4. So I got to do 4 minus 4 to get 0. And the y coordinate is negative 3. Negative 3 plus 1 is negative 2. Alright, so there are my coordinates for the image. Let me graph them. P prime is at negative 2, comma 0, which would be right there. That's P prime. Let me write it up here. P prime. Okay, Q prime is at negative 2, negative 2. And r prime is at 0, negative 2. R prime. And hopefully you're seeing that this is all super easy, because it is. Once you realize how to read it, it's super simple. Okay, let's go on to the next slide. We're moving along really fast. There's the answers. I'll upload them in the PowerPoint to the Microsoft Teams page as soon as I can. Okay, so I'll go through all these questions, which are all going to be on your assignments. We've already done them, all right, but just to make sure everybody's clear. I'll try to do them a little quicker this time. Okay, so number 5. First they give us our pre-image. A is at negative 3, negative 1. B is at negative 2, positive 2. And C is at 0, negative 1. Alright, now the vector is 3, comma 2. That means you got to add 3 to all the x coordinates and add 2 to all the y coordinates. Alright, so just for the sake of moving a little faster, let's try to do it mental math, alright? So point A is at negative 3, so if I add 3 to it, it'll be 0. You know what, let me write it out. I don't want to lose anybody. Alright, so once again, point A is at negative 3, and I gotta add 3 to it. That'll give me 0 to get for my A prime x coordinate. Okay, and the y coordinate is negative 1. I add 2 to it, that's positive 1. The better you know how to add and subtract positive and negative numbers in your mind, the easier this stuff is. If you're struggling to keep up, it's because you're weak at adding and subtracting positive and negative numbers. Okay, the basics of math, adding, subtracting, multiplying, and dividing, are the key to being awesome at math. If you're weak at the basics, you're always going to struggle with this stuff. So that's the stuff that you got to fix. I have no doubt that everybody understands what I'm going over here. If you're struggling to keep up, it's the adding and subtracting part that's messing you up. Alright, let's look at B. Alright, so B, the x coordinate is negative 2. I got to add 3 to it. Negative 2 plus 3 is positive 1. And the y coordinate is positive 2. Positive 2 plus 2 is 4. Alright, C prime, same thing. Alright, the x coordinate is 0. 0 plus 3 is 3. The y coordinate is negative 1. Negative 1 plus 2 is positive 1. Alright, so now I graph those new points. A prime is at 0, comma 1. B prime is at 1, comma 4. And C prime is at 3, comma 1. Alright, I'm not going to do these because they're all the same thing. Okay, I will display the answer in a second, but I'm not going to do these. Just to look at number 8 real quick. Find the coordinates of the image under the transformation. Okay, so again, here's our vector in component form. The 6 tells us that we got to add 6 to whatever x is. And the minus 11 or the negative 11 tells us we got to subtract 11 from whatever y is. So if I were to write the rule here, I would write this: x plus 6, hold on, x plus 6 and y minus 11. That's how I would write the rule. Underneath it, I'm actually going to work that out. Okay, so if x is 3, 3 plus 6 is 9. And y is 1, 1 minus 11 is negative 10. Okay, same thing over here. Okay, I'm applying this rule or this vector to these coordinates. Okay, so for the 2, I gotta add 6 to 2. 2 plus 6 is 8. And for the negative 3, I gotta subtract 11 from negative 3. Negative 3 minus 11 is negative 14. If by any chance you're somebody that doesn't get that, Look right here a second. Okay, first of all, realize whenever you subtract 11 from any number, for example, 20 minus 11, you got to go 11 numbers to the left. Okay? I'm going to do the same thing, except instead of starting at 20, I'm going to start at -3. So -3 minus 11, I got to go 11 numbers to the left, except the numbers are going like this. -3, -4, -5, -6. So I end up doing 11 plus 3, which is 14, and it's going to be negative. Okay, let's do this last one. Okay, so the x-coordinate is 4. I got to add 6 to it, so that's going to give me 10. The y-coordinate is -3. Just like this one, I got to subtract 11 from -3. So I'm starting at -3, and I'm doing 11 numbers to the left. So it's going -4, -5, -6, -7. So -3 minus 11 will give me -14. Okay, last one. Name the vector. Write it in component form. Okay, name the vector. Okay, to name the vector, I would put this symbol. I start with the initial point and then the terminal point. So that's the name of the vector right there. And then to write it in component form, I would do these little, I'm not sure what the correct term is for these. I'll call them sideways V or something. But okay, so it's going to the right. 1, 2, 3, 4, 5. Sorry, I didn't do a good job of 1, 2, 3, 4, and 5, because the terminal point is right here. So it's going to the right 5 times, and it's going down 1, 2. If you go down, you got to subtract 2. So if you go to the right, you add that number. If you go to the left, you subtract the number. If you go up, you add the number. If you go down, you subtract the number. Okay, so since it went, the x-coordinate, you got to move it to the right 5 times. That means you add 5 to all the x-coordinates. And for the y-coordinate, since this vector is telling us to move the figure down 2 units, that means from the y-coordinate, you got to subtract 2. All right, moving on. Those are the answers, which will be uploaded in the PowerPoint. Okay, and moving on. Okay, I believe for regular geometry classes, I believe this is the last problem. Let's look at how quickly you could do this. And guys, you see there's a lot of numbers here? It's super simple. Don't panic just because it looks a little complicated. I promise you it's not. It's very simple. Alright, so look, it says match each set of coordinates for a pre-image with the coordinates of its image after applying the vector 3, -8. Okay, so here are the coordinates of the pre-image for 4 different shapes. We got to match them. In other words, put the correct letter A, B, C, or D to see after you do this vector, after you apply this vector to these pre-images, which one of these shows the correct image after this vector has been applied to it. Alright, so this vector, again, since there's a +3 here, that's saying that whatever x is, you got to add 3 to it. And the -8 here is telling us that whatever the y-coordinate is, you got to subtract 8 from it. Alright, so let's start with the first one. And look how quickly you could do it. Alright, this number is number 1, so I got to add 3 to it, which is going to give me a 4. Now look at the other ones. None of the other coordinates for the pre-image starts off with a 1. So that means I could just do that one and find my answer very quickly. Alright, so 1 plus 3 is 4. So obviously it has to be this one right here, which has a 4. Alright, this is going to be A. Now if you're feeling unsure, let's confirm. The y-coordinate 1, I got to subtract 8 from it, which will give me -7. So that checks out. Okay, let's do this one too, just to be sure. 10 plus 3 is 13. Yeah, that's right. And 1 minus 8 is -7. Yeah, that's right. So this is the right one. Alright, let's go to B. Alright, so B, this is a 0, so I got to add 3 to it. Alright, so there's only one with 3, so it's got to be this one. I think by now you can see how simple you could do this. And 0, you got to subtract 8 from it. So yeah, I'm just confirming that it's this one. Yeah, it is. Let's go to letter C. Alright, for the first point, the x-coordinate is 3. So 3 plus 3 is 6, so it's got to be this one. And last one, the letter D. This is negative 2. Negative 2 plus 3 is positive 1. And that's it, I'm done. All I had to do was the first number for each one of them to get my answer. I mean, the only case where you would have to do more work or more checking is if some of these had the same number. Then you may have to check a little bit more to make sure which is the correct answer. But that was pretty simple. As you can see, those are the correct answers. Okay, and we're up to, I'm sorry, I thought that was the last part, but we do have one more section here that we got to go over. Okay, on this one, this is the last section where you have to write the vector in component form by looking at the picture. All right, you have to write the vector in component form by looking at the picture. Okay, so as it says here, you may be asked to specify a translation that carries a given figure onto another figure. You can do this by drawing the translation vector and then writing it in component form. Okay, so for example, look how simple this is. They're giving us triangle ABC, which is the pre-image, and triangle A prime, B prime, C prime, which is the image. Okay, really, all I'm going to look at, let me get my pen here. All I'm going to look at is the vector line, the vector right here. Okay, if you look at it, it's going to the right. 1, 2, 3, 4, 5. That's how they got this number right here. You got to move the entire figure is being moved to the right 5 units. So that's why you got to put positive 5 right here in the first column. And it's moving down 1, 2, 3, 4 units. Since it's moving down, that means you got to subtract 4, which is written like that, as negative 4. Okay, let me do another example so you can see what I mean. By the way, right here, they're just showing you all the little details. The horizontal change from the initial point, negative 4, comma 1. Negative 4, comma 1 is right here. That's B. All right, so they're putting the coordinates of B to the terminal point, which is B prime. That's this right here, 1, comma negative 3. Okay, and they're saying if you, let me see here. The horizontal change would be the difference between positive 1 and negative 4. Honestly, this is kind of making it sound more complicated than it is. All right, it's not really, but basically they're saying if you take the starting point, right, negative 4, and the ending point, and you get the difference between them by subtracting, you're gonna get. I made a mistake there. I meant to put positive 1. I'm sorry. You know what, let's go to an example because I feel like I just made things a little confusing. Let's go to the first example of this section here, just 1 second. All right, look. So it says write the vector in component form. All right, so the easy part is this. Pick a point, like for example, oh, I forgot to choose my pen. Made a mistake there, guys, sorry. All right, let's pick point A. So going from point A to point A prime. You could have chosen B to B prime or C to C prime, right? So point A is going to go to the right. 1, 2, 3, 4, 5. And it's going to go up 1, 2, 3. And there's my answer. Okay? Now here they're just telling you that the horizontal change from the initial point to the terminal point. Horizontal is controlled by the x coordinate. Okay, so you would get the difference between 2 and negative 3, which is going to give you 5, because these two negatives become a positive, and 2 plus 3 is 5. Okay, then it says the vertical change. Let me change the color of my pen so maybe, hopefully it'll make it more clear. Okay, the vertical change from the initial point to the terminal point. The vertical change is controlled by the y coordinate. So you would get the difference between the y coordinates, which would be 4 minus 1, and that would give you positive 3. I'm putting the terminal point here and the initial point here. The terminal point here and the initial point here. Or another way to say it, where that the x coordinate of the image here and the x coordinate of the pre-image here, the y coordinate of the image here and the y coordinate of the pre-image here, the x coordinate of your final point here and the x coordinate of your initial point, of your starting point here, and the y coordinate of your ending point here and the y coordinate of your starting point here. Hopefully one of those made sense, all right? But if you look at the numbers, it'll make sense, all right? If you felt like you didn't get that, just look at it slowly and it'll make more sense. All right, let me see if I have another example. I do. All right, so I mean, this is pretty simple. If they give it to you like this, there's no reason to write out the coordinates. You could just count. All right, so I'll do like one more example like this. All right, so let's pick. Always be careful that you're picking a point from the pre-image to get to the image and not the other way around. In other words, like I gotta make sure I'm going from A to A prime and not be careless and by accident go from A prime to A, because then you're gonna get it wrong on the assignment and you may be wondering, why am I getting it wrong? And it's because you're looking at the wrong ones. You gotta start with the pre-image and go to the image. All right, so my pre-image is here. It's going to the right 2 times. So my vector is going to be positive 2 for the first number, and it's going to go up 1, 2, 3. So positive 3 here. That's it. I'm done. Piece of cake. All right. They're all going to be the same, so I only have to do one. Let me do this one over here. Let's pick point C, from C to C prime. All right. So it's going to the right 1, 2. So I put a 2 there, and it's going down 1, 2, 3, 4, 5. Since I'm going down, I got to put -5 or -5, however you prefer to think about it. All right, so last one. This one looks a little more interesting. Again, make sure you start with the pre-image and end on the image. So I'm going to go from A to A prime. Okay, so look. This is something that I'll say a lot, but I haven't said this entire year yet. But I like to say that if something looks a little confusing, just remember how you did it when you had a simple problem and follow the same steps like a robot. Just follow the same steps. That's what I'm going to do right now. Okay, so from A to A prime, it's moving to the right 1, 2, 3, 4, 5. It moved to the right 5 times. Okay, now it did not move up and it did not move down. So right here, I'm going to add 0 to the y coordinates. That's going to keep it the same because the y coordinates did not change. All right, since it did not go up or down, I put a 0 here. Okay, if you want to see what I mean, just look at the coordinates for point A. Point A is located at -4, +4. And point A prime is located at +1, +4. The y coordinates are not changing. So if I put a 0 here, that's saying that whatever the y coordinate is, add 0 to it. I did add 0. When you add 0 to a number, it stays the same. So that's how you would write that vector. All right, let's see what's next. Those are the answers. Okay. All right, and if you're in regular geometry class, we're done. If you're in honors geometry, wait one moment. We have 2 more questions to go over. They're not that difficult. Okay, but for geometry, the assignment is in the student portal. 2.1 translations. It's due by 6 a.m. the next day that you have me. You got to hand it in before 6 a.m. the next day that you have me. Okay, now honors classes. Let's look at this. We have 2 more problems. And honestly, if you understood everything we did so far, they're very simple. It's just hidden in a word problem that I wanted to look at. Okay? So this says, a builder is trying to level out some ground with a front end loader. He picks up some excess dirt at this coordinate point, 9, 16, and then maneuvers through the job site along these vectors to get to the spot to unload the dirt. Find the coordinates of the unloading point, and then you got to write a single vector from the loading point to the unloading point. If you didn't understand that, let me say it a different way. All right, you're starting right here. This is your starting point. They want you to apply this vector to it. Apply this vector to these coordinates. Once you apply this vector to it, then apply this vector to it, and then apply this vector to it to see where is your final spot. Once you find your final spot where you're at, write a vector that summarizes how to get from your initial point to your final point in just one vector. All right, so let me show you what I mean. All right, so you don't have to write everything I'm going to write here, but just so that everybody's with me. Let me write starting point. All right, so my starting point is right here. Whoops, forgot to close the parentheses. All right, so now let me apply the first vector. So my first vector says whatever x is, subtract 6. Whatever y is, add 0. So I'm not sure what's the best way to write this, but let me just put it like this, all right? After I do the first vector, these are now my coordinates. If I subtract 6 to 9, I get positive 3. And if I add 0 to 16, I get 16. All right, now let me change the color of my pen to, I don't know, green. Okay, so now this is the second vector. I gotta add 2 to whatever x is and add 5 to whatever y is. All right, so when I do that, my new coordinates, if I add 2 to 3, I'm gonna get 5. And if I add 5 to 16, I'm gonna get 21. Okay, and let me just change my pen color to, I think this is like pink, I'm not sure. Yeah, or purple, I'm not sure. Okay, so if I apply that vector now to these coordinates, all right, so I gotta add 8 to whatever x is. 8 plus 5 is 13, and I gotta add 10 to whatever y is. Y is 21. 21 plus 10 is 31. Okay, so let's just call this my endpoint. Again, I'm not really sure what's the. If you have like a different method to write this out, that's fine. I just came up with a little system right now as to how I would do it if I had to do it. Okay, now we're not done. Okay, we found the first part of our question, which is find the coordinates of the unloading point. But now the last sentence says that they want us to find a single vector from the loading point to the unloading point. All right, so let me change the color of my pen one last time to black. Okay, in other words, we got to write a vector that in just one vector will tell us how to get from here to here, all right, to our endpoint. Okay, so the way I'm going to do that, I'm going to go like this. Okay, so from 9 to 13, I got to add 4. So that's what I'm going to write there. And from 16 to 31, I got to add 15. And that's it, I'm done. So really, I hope you can see it's not as complicated as it looks. Hopefully the different colors helped you understand. So again, this is my starting point. And to these original coordinates, first I applied this vector, which gave me new coordinates. Then I applied this one to the new coordinates, which gave me some other new coordinates. And then I applied this vector to it to get my final ending point. Okay, and then the last step is to just write a vector that'll take you from the starting point to the end point. All right, and when I upload the PowerPoint, it'll have these answers there. Okay, so as you can see, here's the same endpoint that I had and the vectors, the vector to get us from the starting point to the end point. All right, and last one. This one's pretty simple. Same concept, but this one's even simpler. All right, so this one says that a group of hikers walks 2 miles east and then 1 mile north. After taking a break, they then hike 4 miles east to their final destination. What vector describes their hike from the starting point to the final destination? So we got to write the vector that describes their hike. So remember that the first number in the vector controls the movement right and left, or in the context of this problem, east and west. All right, so if they walk 2 miles to the east, this is north, which is up and down, so let's forget about that for 1 second. And then they hike 4 miles to the east. That means in total, they went 6 miles east, 6 units to the right. Okay, and then for up and down, that's north and south. All right, so the only thing up and down is this. They went 1 mile north, so that's 1 unit up. So that's my vector, that's my answer. All right. And with honors, I just want, whenever I can, I want to try to put in some more real world type problems, or problems that have you think more, because you guys can handle it and it'll make you that much stronger. Okay, so as you can see, there's the answer, and we're done. Your assignment is also in the student portal, 2.1 translations, and it's going to be due by 6 a.m. the next day that you have our class. All right, hope you guys enjoyed the lesson.